Hey everyone. Yes, so my talk is titled From XML to Compose, which will basically be touching on my journey of transforming an existing large Android app to Jetpack Compose. I'm Ahmed Tikiwa. I'm a senior software engineer in Android at a company called Luno. I am based in Cape Town in South Africa. I've been a software engineer since 2010, and Android has been my passion for a very long time now. So this year is focusing on my journey with Jetpack Compose. So the first question we ask is, why Compose, right? Well, most Android development, including my own, included defining layouts using at least one XML file. This XML file would contain a tree of UI widgets constituting an Android view hierarchy. If the user interacts with the screen, for example, this would result in a change in the app state, and thus a need for the UI hierarchy to be updated to display the current data representing the changed state. However, to update the UI, a function such as findViewById is used to go through the hierarchy tree, and then the internal state of the node, which is the UI widget, is updated through functions like setText or addChild. This manual change of the UI widget is very error-prone. For example, trying to set a value to a node that has already been removed from the UI, thus resulting in an unintended exception. The more views that are part of the application, the higher the level of maintenance and complexity. Jetpack Compose was created with the intent to simplify the above and instead accelerate the way in which we develop our UIs using less code and benefiting from a list of powerful tools all in Kotlin. In other words, there's no more XML-defined layouts, which is referred to as the imperative approach. Rather, your views are now defined in Kotlin, in your Kotlin code, which is referred to as the declarative approach, meaning you now describe your UI. So what are other companies saying about Jetpack Compose? At Monzo, they're saying it's much easier to trace through code when it's all written in the same language, it being Kotlin, and often the same file, rather than jumping back and forth between Kotlin and XML. At Twitter, they said, our theming layer is vastly more intuitive and legible. We've been able to accomplish within a single Kotlin file what otherwise extended across multiple XML files that were responsible for attribute definitions and assignments via multiple layered theme overlays. So when was Jetpack Compose introduced? I first heard about Jetpack Compose when it was announced as a preview by Google at I/O in 2019. And this is what Karen had to say from Google, what she had to say about Jetpack Compose at the time. One of the areas we never solved was UI. We really wanted to look at how could you make it super simple to develop UI. Then Leland Richardson had this to say. What I think is once people start seeing Compose in action, it really becomes a delightful thing to program. So like any developer, I was excited as I was already using Jetpack libraries extensively as part of my development, with a new one now being added to further accelerate or speed up my development with even less code. Though I was excited, I was also trying not to feel overwhelmed at the prospect of learning a whole new way of writing UI, as the imperative approach is what I was used to for years. Due to time constraints, I also delayed learning Jetpack Compose until recently. So, learning Compose. I started learning Jetpack Compose through the course on the Android developers website, which takes you through step-by-step into understanding the inner workings of Compose, from thinking in Compose, the basics, navigation, theming, animation, integrating into existing apps, all this through articles, videos, and code labs. Then the course also has a short quiz at the end to test your understanding of Compose, and includes a Jetpack Compose badge, which will be added to your developer profile on successful completion. And then in addition to this, as I'm a visual learner and with a desire to thoroughly understand Jetpack Compose, I went through 2 paid Jetpack Compose courses on Udemy. This approach is, of course, totally optional, but the extra visual tutorials helped me The first was a short course by Katalin Gita called Jetpack Compose Crash Course for Android with Kotlin. And then the second, and a more extensive course by Paolo Deshone, which covers Kotlin fundamentals for those who either need a refresher or are new to Kotlin, and a series of different apps to help solidify the compose concepts and how all the components fit together coupled with state management. Then once I was done with my learnings mentioned above, my desire to now implement Compose into my existing app, Up Next TV Series Manager. So this is the app. I created Up Next TV Series Manager in 2015 as a passion project of mine, and it has been in production since and available for download from the Google Play Store. Up Next is also an open source project. It's also officially part of the Google Developers Dev Library, which is a website and a collection of developers from around the world who have offered up their projects to want to contribute them as part of the Google ecosystem. So these are projects that use Google technologies and are now open source projects. So Up Next is one of these. The app boasts the following screens: a dashboard screen showing a schedule of shows that aired the previous day, the current day, and the next day, provided by the TV Maze API. Then it is a search screen, allowing the user to search for shows with the results displayed in a clickable list of cards with data provided by the TV Maze API. Then it also has an explore screen showing the currently popular, trending, and most anticipated shows provided by the Trackit API. Then there's a show details screen showing a summary of the show, cast information, a rating breakdown from Trackit, previous and next episode information provided by TV Maze and Trackit APIs. Then there's a list of seasons for a particular show displayed in a list of clickable cards with data provided by the TV Maze API. Then you have a list of episodes for a particular season displayed in a list of clickable cards with data also provided by the TV Maze API. Then finally, there's a Trackit account screen, which displays one of two screens depending on whether the user is logged in to their Trackit account or not. If the user is logged in, their list of Up Next favorited shows will be displayed. So adopting the approach, adopting Compose, choosing the right approach. So what makes Jetpack Compose so powerful is that it caters not only to developers creating new apps, but also to developers who have existing apps, in my case, that's me, and would like to include Compose into it. What makes the latter a possibility is the concept of interoperability. What this means is that Jetpack Compose code can live side by side with XML-based code. With that said, adoption can be done in one of two ways according to the Android developers website. The first approach is called the bottom-up approach, and it starts by migrating the smaller UI elements on the screen, like a button or a text view, followed by its view group elements until everything is converted to composable functions. Then the second is the top-down approach, which starts by migrating the fragments of view containers like a frame layout, constraint layout, or recycler view, followed by the smaller UI elements on the screen. So what does interoperability actually look like? Each of my fragments has an XML layout, a layout view associated with it. Some screens also have an additional layout view for recycler view items used by the respective recycler view adapter. And as this is a gradual migration to Compose, where I'm going screen by screen, I'll be completely removing fragment files in future and have Compose navigation, where the navigation will be from composable screen to composable screen, as opposed to the current fragment to fragment navigation. Compose view makes it possible to introduce Compose UI content into an existing XML layout. The Compose view acts as a container to host the Compose UI content, thus making it possible for Android views to coexist with Compose UI in the same XML file. So continuing on with what interoperability looks like. So all the Android views, text views, recycler views, nested scroll view, constraint layout, linear progress indicator, and then my XML layout, and I replace them with compose view. So that's how my XML layout now looks. Then once the app makes use of compose navigation, then the need for compose view will be redundant. Then within my fragment, this is how it's defined. Using data binding, I reference the compose view in order to set it up. So binding.compose container.apply, that's how I'm referencing that compose view within my XML. Then according to the documentation, by default, whenever the view is detached from the window, compose disposes of the composition. My view types such as compose view and abstract compose view use a view composition strategy that defines this behavior. So to ensure unintended behavior and to ensure that compositions are disposed of automatically when not needed, then set view composition strategy is required. As you can see there, that's how I've defined it in the code. Without this, my app actually crashed as I navigated between the composable screens. Then the set content takes in a composable function as a parameter. In this case, it's the theme definition MDC theme. Now, MDC theme is actually part of the MDC theme adapter, which is a dependency which I added to my project to up next. And basically, this allows you to have Jetpack Compose material design into your app. So Jetpack Compose has got a certain specification on how you're supposed to be defining your themes, your typography, and all of that stuff. So it's different to how we were creating it before using XML files. So within Jetpack Compose, it's no longer using XML files. So MDC theme adapter takes care of that for you. It goes through your XML files, provided you are using the standard attributes, and then creates these Kotlin-based theme, typography, color files on your behalf in the background. So you don't actually have to create those. The adapter takes care of that for you. Then when I'm now ready to migrate to Jetpack Compose material design, then I can completely remove the theme adapter and actually use my own theme. So this MDC theme is also a composable, which takes another composable function. In this case, the composable screen, which I created called search screen, as you can see there. So breaking down the changes, starting off with the search screen. My focus on the search screen was the following. So I needed to update the search bar to be a composable, updating the search results list, where I create a composable representing a single result item, and then displaying the list of these single result items or composables representing a search result item. Then I will remove the recycler view adapter, its view holder, and item layout. So this is how I've defined my composable. And I've called this search screen. And this is a function annotated with @composable. However, you ask, what is a composable? So Jetpack Compose is built around composable functions. And within these functions, you can define your app's UI programmatically by describing the UI of your app, how it should look. And also, you provide the data necessary to be displayed. You therefore no longer have to focus on the process of the UI's construction, such as initializing an element, attaching it to a parent, and so forth. You don't need to worry about that anymore because of Compose. So for my composables that represent an entire screen, I like to add screen as part of the name. Also, the composable function name begins with an uppercase. So search screen there, capital S. And this is actually the standard or the norm when creating composables. Then for dependency injection, I use hilt in my app. And because my view models are hilt view models, I can pass hilt view model to allow my view model to be provided here to this composable. The hilt view model call is part of the hilt navigation compose dependency, which I added to up next. Then because the data in my view model is currently being returned as live data, I can transform that live data value into state using observe as state. Every time there will be a new value posted in data, the returned state will be updated, causing recomposition of every state.value usage. Then when I migrate up next navigation to compose navigation, I will then use the scaffold layout, which automatically provides slots for the app bar and the bottom bar. Now, a surface layout with a modifier fill max size to occupy the whole screen will suffice for my use case. Composables can take a modifier, which is basically a companion object that can help you define properties such as padding or clickability and more for your composable. Modifiers are one of the most crucial things you will need when defining your composables. Then the column composable arranges composables contained inside it to be arranged vertically on the screen from top to bottom, as you can see there in the illustration on the left-hand side. And this is what I've added in my surface composable. Then I want to add a linear progress indicator. But in order to ensure that the list does not jump or shift position on the screen when the linear progress indicator is removed from the screen, I rather want to display the linear progress indicator on top of the list. That way, when it disappears, the list remains in its position. To achieve this, I use a box composable, which is comes standard as part of Compose. And it is equivalent to the frame layout in the imperative approach. The box composable allows the views to be on top of each other, as you can see there in the illustration. Then inside this box composable, I have my own composable, which I created called search area. Then I also have the linear progress indicator, which is also displayed if the is loading state is true. So there I'm using the state variable, which I created there, is loading, and I'm using the value. So once it is set to true, then the linear progress indicator is shown on the screen. In other words, recomposed if it wasn't there before, and then removed from the screen. Then before I explain what's going on here, one concept is very important when it comes to composables. There is the concept of state hoisting, which is the process of moving state all the way up to the caller. In that way, it ensures that composables are as stateless as possible. In my case, the caller is my screen. So for this case, it'll be search screen. And the composables below it need to hoist the state up to it as much as possible. There are times when state hoisting isn't always possible. However, it is best practice to make your composables as stateless as possible. As a general rule of thumb, state comes down the composables and events go up. So when composables are stateless, it also makes them easier to reuse as well as test. Then my search area composable will represent the text field for entering the search query as well as the search results. It accepts 3 parameters, the search results list, 2 function arguments on text submit and on result click. These are events that the composable will respond to and hoist up the responsibility to the caller of search area, which is search screen, to decide what to do with that event. So on text submit will be invoked when the user has entered the search query. This event is hoisted up from the search form composable all the way up to search screen. Then on result click is an event invoked when the user clicks on the search result items. This event is hoisted up as well, up from the search results list composable all the way up to search screen. Then here's what my search form composable looks like, which I created. So on the left-hand side is how I'm calling it, and on the right-hand side is a definition of that. It has a mutable state variable called search query state. Then in order to ensure that this state survives the activity or process recreation, using the saved instance state mechanism, I use remember savable. Now the user's query will be remembered in a state variable. So if I rotate the device, it will also be remembered in that case, using the save state instant mechanism. Then my search form composable makes use of a search input field composable, which is a composable I created as a simple wrapper function around the material outline text field, which I will show in the next slide. Then the state variable search query state is then used in the input field. Initially, the value will be empty because it is initialized to an empty string. Then when the user types a value, the onValue change event is invoked, and then the search query state value is updated and it's remembered. So here's what my search input field composable looks like. So on the left-hand side, that's how I'm calling it, passing those parameters there, the input label, the value state, and the on-value change. And on the right-hand side is how I've defined the function. So as you can see, it calls the material outline text field, passing it the input label, the value state, which is a mutable state variable of type string. Then when the outline text field's on value change is invoked, then that event is passed up containing the new value of type string. So my search result list composable takes two parameters, the list to be displayed and a function argument, which will be the on-click event containing the search result item. So on the left-hand side, that's how I'm calling it, and that's how I've defined the composable. So search results list then makes use of the lazy column, which is the equivalent of the recycler view, but more powerful under the hood. Also with this, I've got no requirement for adapters, view holders, and so forth. All I just needed was just composable. So lazy column and its other counterparts, the lazy row, simply take a list and inside the lambda referred to as the lazy item scope and define which composable represents the column or the row for that list, similar to when you'd create an XML layout for a view holder. This time you create a composable that represents that column or row. So in the previous slide where I showed search screen composable, I didn't show the full implementation until I'd covered the above in order to make things clearer first. So this is the full call for the search area composable, where a list is passed to it. And then when the search area composable's on result click is invoked, then search screen, which is now the caller, will then call the nav controller as part of the Jetpack navigation library to navigate to the show details screen. So as you can see, the responsibility lies with search screen as it's the main parent and it handles all those events. So the fun part, the before and afters. So the search screen, this is how it looked like on the left-hand side using the imperative approach. And then on the right-hand side, this is how it now looks using Jetpack Compose. So the app bar and the bottom navigation bar, as I mentioned, I still need to migrate these to Jetpack Compose, all part of the gradual migration, but the content in between that, that's fully Jetpack Compose. So the input field there is using the search form composable, which I created. So it represents that input area. And then I've got the search results list composable representing the list of shows, which will be shown as the user's results have been returned. Then both these composables are contained within search area, which I showed you earlier. Then this is how the dashboard screen looks like on the left-hand side. So the dashboard screen has got shows airing today, and tomorrow. And this is how it looks in Compose. So here I've got a composable which I created called shows row, which uses the lazy row composable. And this lazy row composable allows me to have my composables displayed in a list scrolling from left to right, so horizontally scrolling. And then I can use the same composable which I created, shows row, for the shows airing today and the shows airing tomorrow. So I can reuse my composables, which is one of the beauties of Jetpack Compose. And it's also recommended to make your composables as small as possible and as reusable as possible. Then my explore screen, similar to the dashboard screen, but has got the trending shows, the popular shows, as well as the most anticipated shows. So this is how it looks like on the left-hand side before, and this is the after, using Jetpack Compose. So at the top there, I've got the trending shows row, which uses the lazy row composable. So similar to the dashboard screen. And then I've got the popular shows row, which also uses the lazy row. And then I've got a most anticipated shows row representing the most anticipated shows. And all these use the lazy row to have a list that's scrolling from left to right. Then the show details screen, this is how it looked like on the left-hand side using the imperative approach. And this is how it looks like on the right-hand side using Jetpack Compose. So I've got a composable called backdrop and title. And backdrop and title basically represents the the backdrop image that you see there, so the large image there, as well as the title, as well as the status, is it running, is it ended, and so forth. And then I've got a composable called poster and metadata. And this basically represents the poster, as well as the when the show is airing, the genres, and then the attribution information. And then I'm using the custom, or the standard text composable, which comes as part of Jetpack Compose, to represent the synopsis of the show. Then continuing with the show detail screen. So this is how it looks below the show, the synopsis, right? So you've got the seasons button there, and then you've got the cast information, and then the next episode information. And this is how it looks in Jetpack Compose. So I've got my buttons there, the seasons button, as well as the add favorite button. So that forms part of the show detail buttons composable, which I created. So all my buttons are in there. I can remove or add them as I please. And then my cast information, I'm using the show cast list composable, which is a composable I created. Also using lazy rows, similar to the dashboard screen or the explore screen, to display my cast information scrolling from left to right. And then I created a composable called previous episode and another one called next episode, which represents the next episode and previous episode information, respectively. Then continuing on with the show details screen, I've got the ratings information there as well at the bottom of the screen. And this is how I achieve that using Jetpack Compose. So at the top there, so previous episode, as I mentioned in the previous slide. And then I created a composable called Track It Rating Summary. So all of that you see there is custom built. So I was using the linear progress indicator, which comes as part of Jetpack Compose, to create those progress indicators of the score for that show. And then using a text composable to show the rating there, as well as the number of votes. Then this is the show season episodes screen, where you can see there it shows you the list of episodes within a particular season in a list of cards. And then this is how it looks like in Jetpack Compose. So at the top there, it says season 5 episodes. I've got a composable which I created called section heading text. And this is just my way of trying to standardize all my headings across my app. So I've got a composable called section heading text, which I can use anywhere in my app and just pass in the heading as well as the text itself to be displayed. I've got the composable there, which basically represents the entire list called show seasons episodes. And this basically uses the lazy column. So it allows me to have my list displayed vertically from top to bottom. And then each of the items within show season episodes is represented by show season episode card. So show season episode card represents that single card view that you see there. So it's using the material card view composable, and then the season information, season 5, episode 1, the summary, and all of that stuff. Then this is how my account screen, the Track It account screen, look like on the left-hand side. And this is how it looks using Jetpack Compose. So at the top, again, I'm using section heading text. A composable I'm able to reuse across my app. And then for the list, I've created a composable called favorites list, which uses another type of list composable called lazy vertical grid. So lazy vertical grid is similar to maybe the grid layout, or if you're used to the Flexbox layout. So this allows me to have my items displayed in a grid format. And then each item within the list is represented by a composable I created called list poster card. So what still needs to be updated or converted? I still need to change the toolbar. I need to migrate that to the Jetpack Compose toolbar, or rather the app bar. I need to migrate the bottom navigation bar to the Jetpack Compose version. I've already started on this work. It is on a separate branch, and I will share that the link to my code in just a bit. Then I'd like to migrate the navigation to Jetpack Compose navigation. So currently it's using the standard Jetpack navigation. I'd like to migrate it to Compose navigation. I'd like to remove all the fragment files, and I can only do that once I've migrated to Compose Navigation, because now all my screens are now composables, no longer fragments. Then I'd like to replace surface with scaffold, because I will be using the app bar, the bottom navigation bar. So scaffold allows me to automatically have those slots, as I mentioned in the previous slide. Then I'd like to replace observer state with. This is purely my own preference. There's nothing wrong with observer state. You can actually use it. So if your view models are using live data, you can observe them using observer state within your composables. It's totally fine. And then I'd like to add animations to make things pretty, to make transitions between the different screens pretty, to make how elements will appear on the screen appear very nicely. And then most importantly, I'd like to add tests for my composables. So resources. First one is the official Compose documentation, which you can find at developer.android.com/jetpack/compose. Then the official Compose course, you can find at developer.android.com/course/pathways/compose. Then if you'd like to learn more about the layout basics, this is where you can find that. Then if you want to learn about state hoisting, which I mentioned is a very important concept within Jetpack Compose, this is the URL where you can find that as well. It's also on the Android developer website. Then UpNext TV Series Manager, as I mentioned, is an open source project, and you can find it on the Google Developers Dev Library. And contributions are welcome from the community. Please just read my README as well as my contribution guidelines if you'd like to contribute to the project. And that is me. I'm Ahmed Tikiwa. I'm a senior software engineer and you can find me on Twitter at Ahmed_Tikiwa. Feel free to follow me and post any questions that you might have, and I will gladly answer them. Thank you.